Functional arithmetic is really intuitive. If we see notation that says f plus g of x, what it's telling us to do is just take f of x and add it to g of x. Subtraction is the same way. Oops. We're going to take f of x and subtract from it g of x. Multiplication is the same way. Take f of x times g of x. And division is the same way. But we do have to pay attention with division. It is going to be f of x over g of x, but we have to pay attention because we can never have the denominator of a fraction equal 0. So let's let f of x equal 4 root x and g of x is negative 9 root x. If we want to add those two together, remember we're taking f of x and adding g of x. So we take 4 root x and add to it negative 9 root x. When we combine like radicals, we're going to leave the radical the same, and all we do with the coefficients is add them together. We'll combine 4 plus negative 9 and we'll get negative 5 root x's. Subtraction is the same way. So if we have f minus g of x, we're going to take f of x and subtract from it g of x. So the same idea. 4 root x minus negative 9 root x. Now don't be scared of subtracting a negative, of course. That's the same as adding. So we're going to add 9 root x, and we'll have 13 of those root x's. Let's use h and k to multiply and divide. If we're going to multiply h times k of x, that's h of x times k of x. So 6x times x to the 3/4. And remember, when we multiply two exponents with the same base, we just add their powers. So 1 plus 3/4 is 7/4. For division, I'm going to take 6x divide by x to the 3/4. So when we combine these two powers, or these two exponents, what we do is we subtract their powers, and 1 minus 3/4 is 1/4. But we have to pay attention. Alright, even though this function, our solution looks just fine, like it could use any number we want, remember this thing came from being a fraction, and in this fraction we can't let the denominator equal 0, so x can't equal 0. A problem that you probably won't see in your book, but is a great problem when talking about functional notation, is if we look at the functions as sets instead of just equations. Okay? So if we let A be a set of ordered pairs, 1, 2, 4, negative 1, and 0, 9, that means there's 3 elements in our set. And we're going to want to add that to B that also has 3 elements in a set, which might not be the case. They don't necessarily have to be the same size. Now if we look back to these definitions of addition, subtraction, multiplication, and division, what we're adding and subtracting and multiplying and dividing are actually y coordinates. Remember, if we have an ordered pair xy, how we find out what the y coordinate is by plugging it into the function. So it's really x comma f of x. So when we want to do this addition, f of x plus g of x, what we're really going to add together are the same y coordinates. We don't do anything to the x coordinates. So back to this example, if we want to find out what a plus b is, it's going to be a set, and the first thing that we look at is just when x is 1. All right, for when x is 1, we're going to add the y coordinates together. 2 plus 5 is 7. Then we move on to the 4s. And at 4, we're going to add the y coordinates. Negative 1 plus 0 is negative 1. And then we finish up by looking at the 0s. Add the y coordinates. 9 plus negative 3 is 6. And there's our solution. If we're going to multiply the same thing, you look at the 1s and multiply the y coordinates together. Then we look at the 4s and multiply the y coordinates together. And then we look at the 0s and multiply the y coordinates together. And there's our set. Be careful when it comes to division, because we're going to look at the 1s and now divide the y coordinates. 2 divided by 5. That's fine. But when we look at 4 and we divide the y coordinates, we're going to have negative 1 divided by 0. And we can't have 0 in the denominator. That's a problem. So we take it out of our set and just move on to the next time, or the next element. when x is 0, and divide the two y coordinates. 9 divided by 3. So of course we should simplify that into 1 comma 2/5 and 0 comma negative 3.